Okay, so page 6, just wanted to kind of recap these problems. These are a little bit easier to graph because we don't have to worry about a change in period. Notice that all these problems here, again, I'm putting parentheses around that theta, emphasizing that that theta is inside the cosine. It's not cosine times theta, it's cosine of theta. And look at all these theta values. There's nothing impacting that theta value. There's no coefficient in front of that theta. There's no divisional expression that is part of, which means that your period is not going to change. It's going to be your parent 2 pi. So now if there's anything done to that theta, then we're going to be experiencing a stretch or a compression within our cycle. So these problems are a little bit easier because all we need to do is we have to fill out our subintervals, and these are just quadrant angles that we're used to: 0, pi over 2, pi, 3 pi over 2, and 2 pi. From there, we know that our general pattern for cosine starts at the max, then it works its way down to -1, and then back up to its max, starting point. And if there's an amplitude, in this case, there's a 5, we multiply all the y values that we gather from our parent cosine function and multiply by 5. Okay. And I want you to graph 2 cycles, a positive and a negative version. Okay. For sine, we know that the pattern starts at 0, rises up to its max, comes back down to the midline, then to -1, and then to 0. The difference with 3 and 4 is that now the a value is a negative, which means that when I multiply those initial y values of cosine, the signs will change. So -1/3, 1/3, -1/3, which means that our graph looks a little bit different, right? Cosine, we're used to seeing it starting at the max and then making its way down, but everything is flipped. So now it's going to start at the minimum and then rise to the max. Okay. Same thing here with the sine function. Normally, we know the sine starts at 0, rises up to 1, but in this case, it's going to start at 0, go down to the minimum because of the reflection, and then rises up and then comes back down to 0. Okay, any questions here? Okay, so let's go to, so we're just basically going to be staying with this topic, but we are going to practice more with graphing when there's a change or shift in period and interval. Okay. But there's a few things here I want to go over. Next page. So next page. Okay, so these are pretty easy and straightforward, I think. It says write an equation with the given properties. So right now, we have a sine of theta, a cosine of theta. Now we can also include the fact that there's a b theta. But we're going to see that for this page, we're not going to. There's not going to be much impact with the period. It's just going to be the amplitude. So if sine function with an amplitude of 0.4, what's that going to impact? The a, right? So amplitude of 0.4. So we say y equals 0.4 sine of theta. Technically, amplitude of 0.4 could mean that the a is positive or negative. So we could say plus or minus, but it just says write an equation. But technically, an amplitude of 0.4, a of -0.4 could also work. Right. So 6 through 8, these are all really just taking that amplitude and then just insert it where the A variable is. If it's an exact value, it doesn't matter. Yeah. But if it's like 2/3, then we definitely want 2/3 rather than 0.6667. Yeah. So, but either is fine as long as they're both exact. Okay. So no challenge there, right? You're just taking whatever amplitude they give you and then just insert it in for the A variable. Okay. So let's see if we can identify what type of a graph we're looking at and the equation just based off of what we see. So let's look at number 9. Okay, so look at number 9 here. What graph does that look like to you? Does it look like sine or does it look like cosine? Sine, right? We start at 0, we go up, so we know there's no reflection going on. And it completes its cycle within what we expect, right? Complete the cycle because after 2 pi, it starts to repeat, right? So we know the B value is not going to change, but the A value is going to change though, right? What's the amplitude going to be for number 9? 1/2, right? I mean, that's the best of our ability in terms of estimating. Looks like it's hitting a max and min of 1/2. So that's our amplitude. Okay. All right, number 10, what does this graph look like to you? Looks like the cosine, right? Starts at the max, works its way down to 0, then to the minimum, up to 0, up to 2 pi. So it looks like it's fulfilling its complete cycle within 2 pi. So we know the B value is not going to change. But the amplitude is now going to be what? 4, right? You see that the distance from the 0 or the middle of the graph to the max is going to be 4 units. Okay, number 11. What does that look like to you? Yeah, it looks like a sine function and amplitude of 2. And finally, that looks like a cosine with an amplitude of 1/2. Okay.
Cosine doesn't start at 0, right?
That's right. Cosine starts at either the max or the min, depending on whether it's reflected or not. But if it's not reflected, it starts at the max. Okay. Okay, we're going to do, so we're going to gather information on this page and then be able to work backwards and forwards with an equation. And then so we're just going to do page 8 and 9 in class today. Your check-in quiz will be coming from page 8 and page 9. So I'll go over, after we go do this, I'll go tell you exactly what to expect on the check-in quiz tomorrow. Yeah. So, but it's just 3 problems. We're going to see, you'll know exactly what to expect for the check-in quiz. Okay, so let's look at number 1 here. It says state the amplitude and the period for each function. The first thing we want to do is we want to gather our A and B values. Okay, so number 1, what's our A value? Okay, -2/5. And then, and then A value is -2/5. Our B value is 9. Okay. Now it's asking for the amplitude. Amplitude is always the positive version of your A value. Okay. So in this case, amplitude is just what? Just 2/5. Okay. And to find our period has a formula. Is 2 pi over B. So that's something we need to make sure we memorize for tomorrow's check-in quiz. Okay. So we just say 2 pi divided by 9 if we were to graph this, we would have to do 1/4 times period to find the interval, but we'll do that later. Okay, but right now we're just gathering information about amplitude and period. Okay, so what this means is that it's now going to complete its full cycle in a very short amount of time, right? 2π/9. Okay, number 2. A is 2/3, B is 3/7. Again, sometimes they don't put parentheses, but I think it's good to put parentheses as a reminder that you're looking at an expression that is inside the trig function. We never want to think of it as cosine times 3/7, right? So that 3/7 is not at the same level as the 2/3. Okay, so amplitude is 2/3. Period is 2π divided by b. So dividing by a fraction is same thing as what? Multiplying by the reciprocal, right? That way you don't have to think about in terms of dividing by another fraction here. So just multiply with the numerator, 2π times 7. Okay, number 3. A is negative 2.5. Now look at how this is set up. What's the b value? Good. We understand that any fractional numeric value you can push it out in front. So divided by 5 is the same thing as a 1/5 in front of that variable. Okay, go ahead and try that. Can you guys finish 3 and 4? And we can check our answer. Again, you're going to be using this formula. Period is equal to 2π divided by b. Okay, so A value is negative 2.5, B is 1/5. Amplitude is always positive, so amplitude is 2.5. Period is 2π divided by B, 2π divided by 1/5. Dividing by a fraction is the same thing as multiplying by the reciprocal, so 2π times 5/1. 2 times 5 is 10, 10π. Okay, you guys okay there? Number 4, very similar setup. 2π divided by 1/3 is the same thing as 2 times 3, 6π. Okay, any questions with 1 through 4 before we do something that's a little slightly adjusted with the rest? You guys okay? Okay, so here's what number 5 looks like. It's a little bit different in what it's asking because number 5 says, well, it says write the equation of the sine function with each amplitude and period. So rather than giving us the b value, now they're giving us the period value, and we have to kind of go backwards to figure out what the b value is and then put it into our sine and cosine function. So here's our goal here. We're trying to get it into a sine of b theta. Okay, we're trying to get into that form. But to do that, we need to find our a and b value. I think the a value should be pretty easy. What's going to be the a value here? 3. Okay. Now the period is pi over 6. I'll put that to the side here. Now the formula that we're going to be using is the same formula. Okay, so period is equal to 2 pi over b. It's a little bit different, right? Because now we don't have the b value. We have to find the b value. So I'm going to make a substitution. Same formula. It's just that I'm working backwards here. So I'm going to put pi over 6 in place of the period. And now I'm just going to work to solve for b. Okay, does everybody follow what I just did here? Same formula, but instead of replacing b, we're going to replace period because that's what's given to us. Okay, so now I have pi over 6 equals 2 pi over b. If I don't have a fraction, then I'm going to force a fraction, put a 1 in the denominator, but in this case, it's already a fraction. I'm just going to cross multiply, and that way I can just solve for b. So I get b times pi is equal to 2 pi times 6, which is 12 pi. There's no need for me to divide anything. I can just cross the pi's out. So b is equal to what? 12. Now that we have the b value, we can turn around and insert it back into the equation that they want from us in this form. Okay, so that's number 5. Oh, yeah, that's a good point. It says write an equation. So technically, amplitude of 3 could mean your a is positive or negative. So you could say plus or minus, but it says write an equation. But maybe it's good to have plus or minus as a reminder that amplitude of 3 could mean an a value of 3 or negative 3. But on the quiz, if it says write an equation, you can do plus or minus and it doesn't matter. You'd have to just do both. Okay, let me go through number 6 as well, just so if you still have any questions, I can do one more example before I have you guys try the rest. So amplitude is 6, period is 3 pi. So a is plus or minus 6. So again, I'm using the same formula, but instead of starting with the b value, I'm starting with the period. So I'm working backwards to solve for b. So same formula here. But I'm going to put it 3 pi over 1 just so I can kind of match the parts I'm going to combine for cross multiplying. So I'm going to force that 1 in the denominator. 3 pi over 1 equals 2 pi over b. Cross multiply. Divide both sides by 3 pi, or you can cancel the pi to begin with. That's fine as well. Okay. A is plus or minus 6. B is 2/3. I can just insert now into my sine equation. Okay, how do you guys feel about that? Okay, there will be one of these questions on the check-in quiz. Okay. So can you guys finish the rest of the page and see how comfortable you are with each of these problems, and then I'll put the solutions up and we can check our answers. I'll also come around to see if if you need any help.
Are they all sine?
No. Well, 7 through 10 is sine, but then 11 through 16 is cosine. Yeah, just based off the instructions. Have you guys check 7 through 10? You're done with them? Any questions about these? Any ones you want me to go over? That's true. Yeah, you can. I wrote all the b value in front of theta, but if you write it as theta over 2 or theta over 3, that's perfectly fine as well. Okay, give you guys one more minute. I want to make sure I go over all the graphing problems, but I can always come back and go back and show this page. Okay, let's go to the next page, page 9. Okay, so page 9. I'm going to just jump to number 18. 18 and 18, 19, 20 has all the different features that we want to be able to work through with these problems. So I want to change number 18 for a bit here. Can you guys just put a coefficient of 2 in front of cosine 2 theta? That way we can practice with the change in amplitude, the change in b value. So we're going to skip 17 for now and just work 18 through 20. Because these are the problems that as more similar to your quiz problems tomorrow. So y equals 2 cosine 2 theta. The formulas that we're going to have to be able to apply here, I'll put them up here. Understand that I guess this is from the previous page here. So we need to understand that period is 2 pi divided by b. And also, we have to be able to know that interval is equal to p over 4. But sometimes it's easier to push that 1/4 out. Think of it as 1/4 times p. You know, we're having to do this without a calculator tomorrow, so whatever makes your multiplying and working with fractions easier, you're going to take advantage of that. Okay, so 18, we have y equals 2 cosine 2 theta. What's my a and b value? A is 2 and b is 2. Okay. So amplitude is just going to be 2, right? No changes if it's just positive. All right, so period. Here's our formula. 2 pi divided by 2. What's the period? Just pi. So we know that our it's going to just take a lot shorter time for this cosine function to complete the cycle, which means that we need to adjust our subintervals as well, right? Your subinterval is no longer going to be 0, pi over 2, pi, 3 pi over 2, 2 pi. We have to split them up in intervals of 4. So what's our new interval going to be? Pi over 4. Okay, so let me pause for a moment. Any questions so far? You guys okay? So let's create our chart or table. Theta, I'm going to put cosine the 2 theta, and then I'll add in the a value at the end. Create 5 columns. Okay, we're always going to start at 0. And we're going to keep adding 1/4 until we reach the end. Okay, so 0 plus 1/4 is 1/4. 1/4 plus 1/4 is 2/4, which is 1/2. 2/4 plus 1/4 is 3/4. Plus 1/4 is pi. So when you reach that 5th spot, it should match your period. Okay, these numbers will always match here. Okay, where does cosine start? 1. And then we just take all these values and multiply by your a value. So then we go to our graph. We're going to do 2 cycles, one on the positive side, one on the negative side. Once you complete that cycle, they can start here and just match all your order pairs and do the same thing. Okay, questions with 18? Okay, try number 19, and I'll follow up after you guys have a few minutes to start. That's the second one. The one on the second. First row, you're just adding. Oops, I skipped one. Were you guys able to identify the correct period, the correct interval, and then fill in that first row? Okay, we're not going to be graphing this middle row, but it's a good, helpful anchor for our y values. Where does sine start? 0, and it goes up. I can multiply these y values by 4. Just graphing first and third. Sorry, sine starts at 0. Okay. Any questions with 19? All right, try number 20. So I think this problem, I think it helps to make the interval formula 1/4 times 1/4 times the period. That way you're not staring at a fraction within a fraction. You can just do 1/4 times 2/3. That makes it easier to see that the interval is just pi over 6. Okay, keep adding 1/6 until eventually you get to 2/3. I'm sorry, keep missing that 0, that initial 0 there. Okay, yeah, always start with 0, then add 1/6. Okay, cosine starts at the max. And then multiply each of those y values, parent y values, with -1/2. Okay, so your check-in quiz tomorrow will just be 2 problems, 2 similar problems to what you saw on this page, page 9, and then 1 problem from page 8. Okay. Tomorrow morning I'll have a help session. I'll send out a reminder about the check-in quiz. Tomorrow in class,